Hello students, so we are doing exercise 21A, prove trigonometric identities, isn't it? So we have completed till question number 20 in our previous videos, and today we'll start from question number 21 onward. Okay, so let's begin. So this is question number 21 from exercise 21A. Okay, exercise 21 and question number 21, coincidence. Okay, so now in the left hand side we have sin A plus cosec A whole square plus cos A plus sec A whole square. So we are going to use this and prove 7 plus tan square A plus cot square A. Okay, left hand side equals to sin A plus cosec A whole square plus cos A plus sec A whole square, isn't it? This is what we have in the left hand side. So let's square this. Square this means let's apply the formula A plus B whole square. Let us assume this sign as A and this as B. A plus B whole square means A square plus 2AB plus B square, isn't it? So A square plus 2AB plus B square. B square means cosec square A, B square. Are you getting me? A plus B whole square means A square plus 2AB plus B square. Now this is plus, this plus comes here. Now this is also A plus B whole square. So let's apply the formula here also. A plus B whole square means A square means cos square A square plus 2AB cos A sec A. 2AB plus B square means sec square A, isn't it? So this is left hand side. Now you know that sin theta equal to 1 upon cosec theta. You know this formula. This means let us bring this cosec theta here, cross multiply. Sin theta into cosec theta equals to 1. We are just cross multiplying cosec theta with sin theta. Sin theta into cosec theta equals to 1, isn't it? So instead of this sin theta and cosec theta, I can write 1. So same goes here. Cos theta equals to 1 upon sec theta, isn't it? That means cos theta into sec theta, cos theta into sec theta equals to 1. Okay. Now this sin square A plus cos square A. Can you see this? Sin square A plus cos square A. You know that sin square A plus cos square A means 1, isn't it? Sin square theta plus cos square theta means 1. So instead of this sin square A and cos square A, sin square A plus cos square A, I'll write 1. These two are gone now. Okay, this is 1. Now plus 2 sin A into cosec A is 1, isn't it? So 1 plus cosec square A. This is cosec square A. Okay, we should not forget this, cosec square A. Now this is gone, plus this plus comes here. 2 cos A into sec A means 1 plus sec square A, isn't it? Okay, now 2 ones are 2, 2 ones are 2, plus 2 plus 2, 4, 4 plus 1, 5, isn't it? So we write 5 here. Okay, 2 ones are 2, 2 ones are 2, 2 plus 2, 4 plus 1, 5. Now we have here cosec square A. So we need tan square and cot square, isn't it? Since we know that cosec square theta minus cot square theta equals to 1, or cosec square theta equals to, the 1 is already in the right hand side, let us take this minus to the right hand side, plus cot square theta. Are you getting me? So cosec square theta can be written as 1 plus cot square theta. So plus, instead of this cosec square A, I will write 1 plus cot square A. Are you getting me? This 2 is already gone here. Now plus sec square A, we need tan, isn't it? So we know that, let me erase this. Okay, sec square theta minus tan square theta equals to 1. This is the formula, isn't it? So sec square theta equals to 1 is already in the right hand side. Now let us take this minus tan square theta plus tan square theta. So sec square theta can be written as 1 plus tan square theta. That means instead of this sec square a, I will write 1 plus tan square a. Now we have 5 plus 1 6 plus 1 7. Okay, 7. Now let me write this plus tan square theta first, plus tan square a, okay, and then plus cot square a, plus cot square a. So this is what we have in the right hand side, isn't it? Hence proved. Okay, now let us do the next question. We have sec square a into cosec square a in the left hand side, and we are asked to prove this equals to tan square a plus cot square a plus 2, isn't it? So LHS equals to sec square a into cosec square a. Sec square a means 1 plus tan square a, isn't it? You know this formula. Sec square a equals to 1 plus tan square a. So instead of sec square a, I'll write this is equal to, okay, not minus, 1 plus tan square a. So cosec square a means 1 plus cot square a, 1 plus cot square a, isn't it? Cosec square a equals to 1 plus cot square a. So now let us multiply this, okay? First we will multiply with 1 to both the numbers and then with tan square a, okay? 1 into 1, 1 plus 1 into cot square a plus into plus is plus tan square a into 1. Now we will multiply with tan square a. Tan square a into 1, tan square a plus into plus tan square a into cot square a. Tan square a into cot square a, isn't it? So you know that tan theta equals to 1 upon cot theta, isn't it? That means let us cross multiply this cot theta here. Tan theta into cot theta means equals to 1. That means tan square a into cot square a means 1. 1 squared means 1, isn't it? So tan theta into cot theta means 1. So this square means 1 square. 1 square means 1. 1 1s are 1. So no need to write that 1 square, okay? So this is 1 plus, let me copy this as it is for time being, cot square a plus tan square a plus this tan a into cot a is 1 and square, we have square, 1 square means 1. So 1 plus 1 is 2 plus, let me write this tan square a first, tan square a, and then I'll write cot square a, plus cot square a, okay, plus cot square a. So this is what we have in the right hand side. Oh, let me write this 2 later, okay, plus 2, because some of the students they say, oh, the answer is wrong. This is not the wrong. 2 plus 3 and 3 plus 2 both are the same thing, okay? Either you write plus 2 in the front or whether you write plus 2 later, that doesn't make any sense. The same thing equals to RHS. But some of the students they argue that the answer is wrong. This is not wrong, okay? So tan square a plus cot square a plus 2 is in the right hand side, hence proved. I hope you got this. So the next question, 23, we have 1 upon 1 plus cos a plus 1 upon 1 minus cos a in the left hand side, and we are asked to prove this equals to 2 cosec square a, isn't it? So let's begin. Left hand side equals to 1 upon 1 plus cos a plus 1 upon 1 minus cos a. This is what we have in the left hand side. Now let us take the LCM of these two. 1 plus cos a into 1 minus cos a, isn't it? 1 plus cos a into 1 minus cos a. If suppose 2 upon 3 plus 4 upon 5. These two are the fractional numbers. So what we do while taking the LCM of the denominators, if the number is not the same, if they are not the multiple of the same numbers, then what we usually do is 3 into 5 is 15, 3 5s are 15, and 5 2s are 10, plus 3 4s are 12, isn't it? 10 plus 12 is 22 upon 15. We write this way, isn't it? So here also 1 plus cos A and 1 minus cos A is totally different thing. They are nowhere close to each other. Okay, one is 1 plus cos A and another is 1 minus cos A. So we multiply these two. Now here what we write, 1 minus cos A into 1, 1 minus cos A, plus 1 plus cos A into 1, 1 plus cos A. So this is minus cos A and this is plus cos A. So let's cancel this out. 1, this is plus, okay, plus 1. If there is no sign in the front means plus. Plus 1, plus 1, plus 2, isn't it? So 1 plus cos A into 1 minus cos A. 1 is A and cos A is B, okay. A plus B, A minus B means A square minus B square, A square minus B square, isn't it? So 1 square is 1 into 1, that is 1. So I didn't write 1 square, okay. Actually this is 1 square. 1 square minus cos square A square minus B square. So 2 upon 1 minus cos square A is sin square A, isn't it? You know this formula very well. Sin square theta minus cos square theta equals to 1. So sin square, this is not minus, okay, sin square theta plus cos square theta equals to 1. So sin square theta equals to this 1 is already in the right hand side. So plus cos square theta becomes minus cos square theta. So 1 minus cos square theta is sin square theta. So instead of 1 minus cos square A, I write sin square A. Now you know that sin theta is the reciprocal of cosec theta. Sin theta equals to 1 upon cosec theta, and cosec theta equals to 1 upon sin theta, isn't it? So this means this sin square A is in the denominator. If you take this number to the numerator, it becomes cosec square A. Are you getting me? Cosec theta when goes to the numerator becomes sin theta. That means sin square A when goes to the numerator becomes cosec square A. So this is what we have in the right hand side, equals to RHS. Hence proved. 24. This question is similar to the previous one. 23. Okay. Left hand side equals to 1 upon 1 minus sin A plus 1 upon 1 plus sin A, isn't it? This is what we have in the left hand side, and we are asked to use this and prove 2 sec square A. So let's take the LCM of the denominator. 1 minus sin A into 1 plus sin A, isn't it? So let's multiply this. 1 plus sin A into 1, 1 plus sin A plus this plus comes here. 1 minus sin A into 1, 1 minus sin A. Now this plus sin A and this minus sin A cancels out. So 1 plus 1, this is plus 1 and this is plus 1. So 2 upon, this is A minus B into A plus B, isn't it? So A square minus B square. So 2 upon 1 minus sin square A means cos square A, isn't it? So cos square A is in the denominator. So if you take to the numerator, it becomes sec square A. Because cos and sec are the reciprocal of each other. So that means cos square A when goes to the numerator becomes sec square A. So this is the right hand side, isn't it? Equals to RHS. Hence proved. So this question number 25, we have cosec A upon cosec A minus 1 plus cosec A upon cosec A plus 1 in the left hand side, and we are asked to prove this equals to 2 sec square A, isn't it? So LHS equals to cosec A upon cosec A minus 1 plus cosec A upon cosec A plus 1. Now let's take the LCM of these two denominators. LCM will be cosec A minus 1 into cosec a plus 1. Now let's multiply this. Cosec a into cosec a, cosec square a plus cosec a into 1, cosec a, isn't it? Plus, let's multiply this to cosec a into cosec a, cosec square a minus cosec a into 1, cosec a, isn't it? So this plus cosec a minus cosec a gets cancelled. So cosec square a plus cosec square a is 2 cosec square a, isn't it? Cosec square a plus cosec square a, 2 cosec square a. In the denominator we have a minus b, a minus b, a plus b. That means cosec square a minus b square. 1 square means 1. So now 2 cosec square, you can take this cosec square to the denominator and make sine square a, okay? So let us write that. 2 upon this cosec square a goes to the denominator and becomes sine square a, okay? We need sec square a, isn't it? So into cosec square a can be written as sine square, 1 upon sine square a minus 1. Are you getting me? This 2 is this 2. Cosec square a is taken to the denominator and becomes sine square a into this cosec square a means 1 upon sine square a minus 1. Okay, now let me continue here. 2 upon the sine square a is already here. Now let us take the LCM of 1 and the sine square a. LCM is sine square a, isn't it? 1 into 1, 1 minus sine square a into 1, sine square a. Now this sine square a and sine square a can be cancelled, isn't it? Equal to, we have 2 in the numerator, 1 minus sine square a in the denominator. 1 minus sine square a. So this is 2 upon 1 minus sine square a is cos square a equals to cos square a. When we take to the numerator becomes sec square a. 2 sec square a. This 2 is this 2 already. It was in the numerator. Now cos square a goes to the numerator and becomes sec square a. This is what we have in the right hand side. RHS. Hence proved. I hope you got this. Thank you so much for watching this video. And stay happy, stay tuned, and don't forget to subscribe and click on the bell icon to get notifications for more video uploads. Okay, thank you.